We're going to use the following slides to look at igneous rocks up close and personal. Now you know that igneous rocks form from molten minerals, ones that have literally been melted and then have a chance to solidify. And as they solidify, they grow crystals. And depending on how quickly they solidify, depends on how quick those crystals grow. Now, sometimes those crystals have time to grow right into each other and interlock. And that actually makes the rock a lot stronger because they lock together and they can't move apart easily, so the rock becomes extremely hard. So that interlocking is important. We're going to have a look at that. The other thing you're going to be looking at is the different colors that are in the rocks. You don't always see these, but when you look at them under a microscope, you can actually see the different types of minerals that form the rock. And each one looks slightly different. They have their own different colors and textures and patterns. So we're going to look at them as well. Now, one big thing you can tell just from looking at a rock with your eyes is whether we call it mafic or felsic, and that just depends on what type of minerals make it up. Mafic rocks have very dark minerals in them. Felsic rocks have very light minerals in them. Here is bronzite. Now, this little guy here looks beautiful to look at, and you can just see some flecks of gold and some brown, but when you actually look at him under a microscope, he's a lot more colorful than that. So this is bronzite up close and personal. Each one of these different colors is a different mineral salt, and as you can see, they're fitting together like this, and that fitting together is what I mean by interlocking. So this means that this rock has had enough time for the crystals to grow into each other. So it's most likely that it was actually formed underground, because if they cool really quickly, that sort of interlocking, it doesn't usually happen. Here's an example of a rock that is formed on top of the earth, often in the very top of volcanoes where the lava comes out. It's called basalt. You see this everywhere around Glasshouse Mountains, and sometimes the rock cools so quickly that the crystals don't even have time to form at all. You just have areas of what looks like black in the rock. You see, you only get light coming through the rock and showing up different colors if it has grown a crystal. If it has just solidified without growing into a crystal, the light actually just gets blocked and can't come through. So this is what basalt looks like to us, and this is what basalt looks like under a microscope. Tiny little crystals, lots of area of black here, which means no crystals even got to form at all. And notice how these little crystals don't have a chance to interlock together. They're all separate. So that tells me that this rock cooled really quickly. Its crystals are really small. It's an extrusive rock. And it is, because it's found in lava flows on top of volcanoes. Here's another example. This is granite. Now, this is a highly prized rock. We use it in our kitchen counters all the time. And it's found usually in eroded earth, or we have to dig it up from the ground. So that's already a clue as to where it actually formed in the first place. But let's have a look. Number one, I can see with my eye crystals even here in the rock. Okay, whereas with basalt, you can't see a lot of crystals. You can see an awful lot of just black area here, not a lot of crystals. Granite, crystals. Have a look up close. Crystals, lots of different types of minerals in this granite here, and yes, they actually interlock and form into each other and fit to each other. So granite, there's your proof there. It was formed slowly over time. It's going to be an intrusive rock. It was formed deep under the earth. Here's latite. Now this little guy is found on surfaces around volcanic eruptions. So usually they find it a little way away from the volcano sometime, like it's been thrown in the air. Well, let's have a look at it up close. I can't see any really big crystals here with my eye, so that's my first clue. I think it might be an extrusive rock because it doesn't look like it's grown many crystals. Up close though, you can see it has got crystals in here, and some of them sort of fit together, but not a lot. There's an awful lot of black here. So this little guy here is definitely an extrusive rock. It was formed on the surface and it cooled really quickly. So now use that information to go and have a look at more igneous rocks with your rock exploration kits.